You cannot install a non-fused safety switch with a 30 amp rating in the same circuit where a transformer's overcurrent protection is set at 40 amps due to derating. The fundamental principle here revolves around protecting the transformer itself from overcurrent conditions. The transformer's nameplate specifies a maximum output of 25 amps, but the overcurrent protection is provided by a 40 amp device. This seemingly contradictory situation arises because of derating. Derating refers to the practice of reducing the rated capacity of a device or conductor under specific operating conditions such as high ambient temperature or continuous loading. In this scenario, the transformer is likely derated due to factors that limit its ability to dissipate heat effectively, preventing it from operating continuously at its full 40 amp capacity without exceeding its temperature limits. Because of this derating, the maximum continuous operating current of the transformer is effectively limited to 25 amps, even though the overcurrent protection device is rated higher. Installing a non-fused safety switch with a 30 amp rating would violate the basic principle of overcurrent protection. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect electrical equipment and conductors from damage caused by excessive current flow. The overcurrent protection device should be sized to protect the weakest link in the circuit, which in this case is the transformer itself, limited to 25 amps continuous operation due to derating. If you install a 30 amp safety switch, it would allow current to flow through the transformer exceeding its safe operating limit of 25 amps, but still below the 40 amp overcurrent protection setting. This creates a dangerous situation because the transformer could be subjected to sustained overload conditions, leading to overheating, insulation breakdown, and potentially catastrophic failure, including a fire. The purpose of the safety switch is to provide a means of safely disconnecting the transformer from the power source for maintenance or repair. It is not intended to provide overcurrent protection. Overcurrent protection is the sole responsibility of the circuit breaker or fuses. However, the safety switch must be rated to handle the maximum available current in the circuit without overheating or failing. In this case, since the transformer is derated to 25 amps, the safety switch must be rated at 25 amps or less to ensure that it will not allow excessive current to flow through the transformer. The National Electrical Code, or NEC, provides specific guidelines for overcurrent protection of transformers. NEC Section 450.3 provides requirements for transformer overcurrent protection. The specific requirements depend on the transformer's voltage rating and impedance. However, the basic principle remains the same: the overcurrent protection device must be sized to protect the transformer from overload and short-circuit conditions. In general, the primary side overcurrent protection for transformers rated over 600 volts should not exceed 125% of the transformer's rated primary current, where the transformer primary current is calculated by dividing the transformer volt-ampere rating by the primary voltage. For transformers rated 600 volts or less, the primary side overcurrent protection should not exceed 125% of the transformer's rated primary current if the transformer has an impedance of 6% or more. If the transformer has an impedance of less than 6%, the primary side overcurrent protection should not exceed 300% of the transformer's rated primary current. The secondary side overcurrent protection for transformers rated 600 volts or less should not exceed 125% of the transformer's rated secondary current. These overcurrent protection limits may be increased to the next standard size fuse or circuit breaker if the calculated value does not correspond to a standard size. However, the overcurrent protection device should never be sized larger than necessary to protect the transformer. In your specific case, the 40 amp overcurrent protection is likely permitted because the transformer has a relatively lower impedance and the calculated overcurrent protection value is close to 40 amps. However, even though the 40 amp overcurrent protection is permitted, it is crucial to recognize that the transformer is still limited to 25 amps of continuous operation due to derating. Therefore, the safety switch must be rated at 25 amps or less to prevent overloading the transformer. To ensure compliance with the NEC and to protect the transformer from damage, you must install a non-fused safety switch with a rating of 25 amps or less. Installing a higher rated safety switch would create a dangerous situation and could void the transformer's warranty. Consider a similar example involving conductor ampacity. Imagine you have a conductor with an ampacity of 30 amps. This means the conductor is designed to safely carry 30 amps of continuous current under normal operating conditions. However, the conductor is installed in an environment with high ambient temperatures which require you to derate its ampacity by 20%. This derating reduces the conductor's allowable ampacity to 24 amps. Now, suppose you have a circuit breaker protecting this conductor. The circuit breaker is initially rated at 30 amps, matching the conductor's original ampacity. However, because of the derating, the circuit breaker setting is too high. If a fault occurs that causes 28 amps to flow through the conductor, the circuit breaker will not trip, even though the conductor is now overloaded beyond its safe operating limit. This overload can cause the conductor to overheat, potentially damaging the insulation and creating a fire hazard. To properly protect the conductor, you must reduce the size of the circuit breaker to 24 amps or less, matching the conductor's derated ampacity. This ensures that the circuit breaker will trip before the conductor is overloaded. The same principle applies to the transformer in use situation. Even though the overcurrent protection is set at 40 amps, the transformer is derated to 25 amps, so the safety switch must be rated at 25 amps or less to protect the transformer from overload. The safety switch rating should always be equal to or less than the lowest ampacity rating in the circuit, whether it's due to derating, conductor ampacity, or equipment limitations. Ignoring this principle can lead to dangerous situations and equipment damage. Selecting the correct safety switch involves several considerations. Firstly, voltage rating. The safety switch must have a voltage rating equal to or greater than the system voltage. For example, if the system voltage is 480 volts, the safety switch must be rated for at least 480 volts. Secondly, amperage rating. As discussed earlier, the safety switch must have an amperage rating equal to or less than the lowest ampacity rating in the circuit. In your case, the safety switch must be rated at 25 amps or less. Thirdly, horsepower rating. For switching motor loads, the safety switch must have a horsepower rating equal to or greater than the motor's horsepower. This is important to ensure that the switch can safely interrupt the motor's starting current. Fourthly, enclosure type. The enclosure type must be appropriate for the environment in which the safety switch will be installed. For example, if the safety switch will be installed outdoors or in a wet location, it must have an EMA3R or an EMA4 enclosure. Fifthly, number of poles. The number of poles must match the number of conductors being switched. For example, a three-phase system typically requires a 3-pole safety switch. When in doubt, it is always best to consult with a qualified electrician to ensure that the correct safety switch is selected and installed. Incorrect selection or installation can lead to dangerous situations and equipment damage. In summary, the key takeaway is that overcurrent protection and safety switch sizing are crucial for electrical safety. Always ensure that the overcurrent protection device is sized to protect the weakest link in the circuit, and that the safety switch is rated to handle the maximum available current without exceeding the equipment's limitations. This principle is especially important when dealing with derated equipment, as the derated capacity becomes the limiting factor in determining the appropriate safety switch rating.